By August 2026, AI development has abruptly exited its experimental phase, expanding rapidly into every domain, but suddenly striking a rigid structural barrier. For decades, software engineering operated on a standard of shipping products first and addressing consequences later. For frontier AI models, that era has ended. Developers are now caught in a tightening vice. On one side, technical capabilities are becoming commoditized at a blistering pace. Generalized intelligence is moving beyond text and into the physical control of robotics and the abstract logic of advanced mathematics. On the other side of that vice is the sudden assertion of sovereign control. Major global governments have erected hard borders to dictate exactly who gets to touch these models and when. To understand this squeeze, we need to trace the new regulatory regimes in Washington and Brussels down to the architectural breakthroughs that force these laws into existence. Multinational companies and sovereign states are waking up to a reality where generalized intelligence is becoming inexpensive to run, but practically illegal to deploy without pre-approval. On August 2nd, the European Union's AI Act officially activated its enforcement powers. The European Parliament has firmly positioned itself as the choke point for the global software market. The Commission wields a direct mechanism to halt deployment. Regulators can issue an information request to examine architecture and block market access entirely. Stonewalling that review triggers severe financial penalties, exposing developers to a fine of up to 3% of total yearly turnover. Across the Atlantic, a parallel clampdown is taking shape via the June 2nd executive order. The newly finished U.S. framework grants the federal government access to qualifying frontier models for up to 30 days before they are released, allowing officials to test for specific cybersecurity vulnerabilities. While the White House labels this approach as voluntary, the political and market pressures for compliance create a de facto gatekeeping system for the most advanced models. Artificial intelligence is no longer governed as standard software. It has moved into a pre-market approval model, where developers must prove a baseline of safety before their products are allowed to reach the public. Regulators are rushing to build these walls in direct response to extreme jumps in cross-domain generalization, starting in the physical world. DeepMind's release of Gemini Robotics 2 marks a significant departure from its predecessor. Where the previous version was limited to driving a humanoid's upper body for tabletop tasks, this iteration controls the entire body, walking, crouching, and reaching. Intelligence is being extracted from the hardware. Instead of building hand-tuned programs for every machine, developers created a universally adaptable neural core. The friction of hardware adoption is collapsing. A new robotic body with different shapes, joints, and sensors can be adapted to this core in a few hours using fewer than 200 examples. Google remains direct about the current constraints. High-speed movement and fine, multi-finger manipulations remain significant challenges for the model. Gemini Robotics 2 suggests a shift where the specific hardware silhouette becomes secondary to the model driving it. The value increasingly lies in a single brain capable of generalizing across any physical form. That same generalization is accelerating in cognitive domains. OpenAI recently demonstrated this with Astra, an internal version of its next major model family. Astra proved the existence of non-sophic groups, building a symmetry structure that can't be imitated by any finite shuffle. Mathematicians have been hunting for this specific exception since 1999. The model also cleared 3 separate problems from Paul Erdosh's list, mysteries that had shown no progress for over a decade. The technical achievement is mirrored by its economic impact. Generating these verified proofs cost roughly $2,000 in API tokens. If the reasoning required to solve decades-old mathematical mysteries can be executed for the price of a laptop, the cost floor for high-level logical tasks has collapsed. This marks a shift in how the most complex cognitive problems are solved. This commoditization of logic is being weaponized in a fierce pricing war, largely driven by the release of Chinese open-weight models. Alibaba's new 2.4 trillion parameter Qwen 3.8 Max demonstrated the ability to run multi-day autonomous coding loops, writing code, testing it, and fixing its own errors for 16 days straight. Simultaneously, DeepSeek V4 Flash has significantly disrupted benchmark running costs across the industry. At roughly 3 cents per test, it operates at 100 times less than the cost of Claude Fable 5, putting immense pressure on the pricing models of major U.S. labs. This pricing collapse is actively altering market behavior. Bending Spoon's $1.3 billion acquisition of Airtable shows companies buying software platforms specifically to integrate AI capabilities into established workflows, rather than for the underlying equity. The pressure from this shift is straining corporate talent pools. Recent trade secret lawsuits revealed Apple employees soliciting technical help from a former colleague who had left for OpenAI, illustrating the desperate need for specialized expertise. Every near-frontier open-weight release drives the baseline cost of intelligence closer to zero, making the massive premiums charged for closed proprietary models increasingly difficult for enterprises to justify. These technical breakthroughs and the resulting regulatory hurdles are forcing a severe recalculation inside enterprise boardrooms. A PwC survey of over 1,000 director-level executives at U.S. financial services firms maps out exactly how corporations are responding to this environment. The consensus points towards organizational contraction. 80% of executives expect their workforce to shrink by at least 20% over 5 years. When hiring, priorities have shifted. 86% say practical AI skills now carry more value than an MBA. The causation is direct. When an AI model can code for 16 days straight or solve complex mathematical problems for a few $1,000s, human capital must pivot from executing the work to directing the tools. In a market caught between rapidly falling costs and strict new regulatory gatekeepers, the traditional advantages of scale are dissolving. The remaining competitive moat is a workforce trained to wield these tools faster than the government can restrict them.